Hey everybody, Dr. A here, and in this video we're going to be going through an example of analyzing vector components using a vector parallelogram. So let's go ahead and get started. In the given information, we're being asked to determine the magnitude and direction of the resultant force using a force vector parallelogram and triangle. We're also being told to measure the orientation of the resultant force counterclockwise from the positive x-axis. So let's take a look at the figure we have here. Here we have an x-axis and a y-axis, and we're given two force vectors. One of them is 100 pounds with a 10-degree reference angle from the positive x-axis. The other is 140 pounds with a 20-degree reference angle from the positive y-axis. Now again, we're being asked to do this using a force parallelogram and triangle. We are not looking at rectangular components for this example, so keep that in mind. So let's go ahead and get started with the solution. I'm going to write solution here, and I'm going to say let's start by drawing the force parallelogram. Okay, we sometimes call this a vector parallelogram. Okay, and so how do we do that? Well, I'm going to redraw this figure. Okay, I'm going to redraw it, and so I'm going to do that by saying copy, and I'm just going to paste it here. So I'm redrawing it that way. And then what I'm going to do is I'm going to sketch this parallelogram, okay, this vector or force parallelogram. How do I do that? Well, if you remember and you maybe watched my previous video, what we do is we draw a line that's parallel to this 100 pounds from the head of the other vector. And then we also draw a line parallel to this 140 pound vector from the head of the 100 pound vector, okay? That's how we're going to do that. Now, in order to draw this a little bit more nice and clean, I'm going to kind of rearrange some of my labels here so I can create some extra space. There's Y, 140. Let's move this maybe down here. All right, so I'm going to go ahead and draw a line parallel here. And remember that this line, this red line, is parallel to the 100 pound force vector. I'm going to draw another parallel line here. And this parallel line is supposed to be parallel to the 140 pound vector. So if you're drawing this in your notes, you might want to take some time and draw it a lot more nice and neat than I am here. I'm kind of freehanding it here. All right. And so I have this parallelogram, right? I have a line parallel to the 100 pound vector, and I have another line parallel to the 140 pound vector. And then what I'm going to do is I'm going to extend a new vector, which is the resultant vector, from the tail intersection of my two given vectors to the opposite vertex here, okay? And this right here is my resultant force vector. Okay, and again, we went through the background information of this in a previous video. So what do we do next? Well, from this point, we can analyze either one of these triangles, either that lower triangle or that upper triangle, okay? And remember, these two triangles are identical. They're just kind of like mirror images of each other, okay? Now, before we analyze either one of these triangles, what we need to figure out is some information about our internal angles. You notice that we have these kind of external angles, 10 degrees and 20 degrees. We need to find out about some of the interior angles so we can do our analysis later on, okay? So what I'm going to ask us to remember is we want to remember that the sum of the interior angles of a polygon is equal to n minus 2 times 180 degrees, okay? And I summarized this in a previous video, okay? Now, I'm going to go ahead and label these interior angles, okay? I'm going to label this angle phi, and I know that this is also angle phi. And then from there, I can I can start piecing some things together. Now, do I know anything about these interior angles? Well, I think I do, right? I would say that this interior angle here, which is the angle in between the 140 and 100-pound vector, is what? What is that? Well, it's 90 degrees minus 20 minus 10. So that is 60 degrees, okay? Which means that this angle right here is also 60 degrees, all right? And so what I can do now is, back on my polygon angle relationship, I can say that 2 times phi plus 120 equals 4 minus 2 times 180 degrees. Where did I get this 120 from? Well, that's this 60 plus 60, right? So I have phi plus 60 plus 60 equals, n is the number of sides of the polygon, so 4 minus 2 times 180. I do a little rearranging, and I can get phi equals to 120 degrees after I do some rearranging, okay? Now that's important because when I peel out one of these two triangles, I'm gonna need that interior angle phi, okay? So let's go ahead and do that. Remember, we can look at either one of these triangles. I'm gonna peel out and look at this lower triangle. And when I do that, I'm gonna redraw this shape of the lower triangle by translating this 140-pound force vector to this parallel side over here, okay? And that's what I'm going to use to create my force triangle, okay? I'm going to say create a force triangle by translating the 140 pounds force to its parallel side, okay? And so let's redraw it. I'm gonna first redraw the 100-pound force here. There's 100 pounds. Now again, I'm gonna draw this 140-pound vector over here, okay? So it's gonna shoot off the head of that 100 pounds vector like this, okay? And so that's 140 pounds, and what's going to enclose this is this resultant force vector right here, which is really what I'm looking for, F sub r. All right. Now, I can go ahead and draw some help lines here, okay? You know, that y-axis is hanging out here. This x-axis is hanging out there, just to give me some references, okay? And then remember, we got phi, so we know this interior angle is 120 degrees. That is this phi right here, 120 degrees. So now what can I do? Well, I can now set myself up to apply law of cosines, right? Law of cosines, all right? What does law of cosines say? Well, it says that the length of one side of a triangle, which in this case will be the magnitude of this resultant force. Remember, the magnitude of a force is its length, is the physical length of the vector, right? So this is just still a triangle, so I'm going to say the magnitude of the resultant force is going to be equal to, I'm going to use my law of cosines formula. Let's see if we remember how to do that. That's 140 pounds squared plus 100 pounds squared minus 2 times 140 pounds times 100 pounds times the cosine of that angle that's opposite the side of f sub r, so cosine of 120, okay? In fact, let me just maybe redraw this down here to be a little bit more neat, okay? I'll redraw it for us. All right, one more time. 140 pounds plus 100 pounds minus 2 times 140 pounds times 100 pounds times cosine of 120 degrees. Make sure your calculator is in degree mode. You'll crank this through and you'll get the resultant force of being 208.8 pounds, okay? And that's part of my answer, okay? But I also need the angle of the resultant vector measured counterclockwise from the positive x-axis. So I need this theta r. Again, theta r is measured from the positive x-axis counterclockwise up to f sub r. To do that, I can use law of sines, okay? So I'm going to say use law of sines to get theta resultant, okay? So watch what I'm going to do. I'm going to say the sine of theta resultant minus 10 degrees divided by 140 pounds is going to be equal to the sine of 120 degrees divided by 208.8 pounds, okay? Now, why did I do sine of theta r minus 10 degrees? Well, remember, you're looking for the angle theta r from the positive x-axis counterclockwise up to f sub r, okay? And so to get that, you have to move through that little 10-degree angle that is already here in between the 100-pound force and the positive x-axis, right? We've got to rotate through that 10 degrees. And so what I'm doing is I'm going to say sine of theta r, which is this total angle, minus this little slither. That gives me what? That gives me this little interior angle of my triangle. So what I'm really saying is sine of this little interior angle divided by this opposite length equals the sine of this 120-degree interior angle divided by its opposite length, okay? So that's why I said minus 10 degrees there, okay? And so I can do some rearranging here, and I will get theta sub r is equal to 45.5 degrees. So my final answer, if I want to summarize this, is the magnitude of f sub r is, you can say that's maybe 209 pounds if you want 3 sig figs, and then theta sub r is 45.5 degrees, okay? And that is my final answer. Again, you want to watch your calculations, especially in your calculator when you're dealing with these trig functions. You want to be in degree mode. If you found this helpful, please hit like and subscribe, and please be on the lookout for other videos like this. Thanks for watching.